What we're going to talk about now is binomial probabilities. And let's go ahead and start with this example of M&Ms. 30% of the M&Ms are covered in speckles, kind of like Easter candy, and mixed randomly with normal candies. You buy a bag and remove candies one at a time looking for speckles. So what is the probability that one of the first three candies is speckled? Well, I'm going to just work out one case where the first speckled one is a third. So I'm going to get regular, regular, speckled. So that means I'm going to do 0.7 because the probability of not getting a speckled is 1 minus 0.3, 0.7. So I'm going to do 0.7 times 0.7 times 0.3. And I get 0.147. So that's one way to get just one speckled candy. Now, if I were to, then I could try to figure out the other ways. Well, the easiest way to do that when we're talking about a small number of trials is a tree diagram. So you have here, how many ways can we draw one speckled candy? Well, you have the way I just did, which was not speckled, not speckled, speckled. But you could also do not speckled, speckled, not speckled, or speckled, not speckled, speckled. The rest of them, I wrote down here the numbers of speckled candies for each path, right? So there's 0 along this path. By the way, if you are doing things where there's more than one outcome, for example, if we were looking at red, blue, and green M&Ms, and I had proportions for each, but I just asked you about blue, you could do blue and not blue to make your tree easier, because if you go red, blue, and green, then you're like, oh, this thing is getting huge fast. So just a general tip, an important one, but a general one. So anyways, the whole point of drawing this tree was to figure out how many ways I could get one speckled candy. Well, there are 3 ways. So I can just go ahead and multiply if I want probability that any of the candies are speckled. And since all the probability calculations are the same along these paths, I just multiply the probability for one of them times 3. Since each outcome is independent, each of the paths for 1 out of 3 M&Ms being speckled has the same probability. We call these Bernoulli trials. All right, so now let's try this with flipping a coin. We're going to do it 4 times, all right? So I want the probability of getting 2 heads. So here's one way to do it. Heads, heads, tails, tails. So you got a half probability on heads, half probability on heads. I kind of grouped it right there. Half probability on tails, half probability on tails, and you get 0.0625. Now, how many ways are there to get 2 heads? Well, I've got this way, that one. I'm counting 6 ways, all right? So all I have to do is take that probability that I calculated up here and multiply it by 6, and I get 0.375. Now, is there a faster method to count 6 ways to get 2 out of 4? So what you can do is you can picture this is flip A, this is flip B, flip C, and flip D. How many ways can we choose 2 out of the 4 total flips to have heads? All right. Well, I could do A, B, A, C. So flip A, flip B. So there's heads, heads. Or I could do heads and then not have my next heads till here. Or I could do heads and not have my next heads till there. And you can see that I count up 6 ways. Why don't I have BA on this list? Well, order doesn't matter. And this looks a lot like doing a combination. So I'm having 4 flips to choose from, and I'm choosing 2 of them to have heads. So you can actually use combinations, which leads us to our formula for the binomial model. This is the combination formula times the probability of getting X successes, and then N minus X, so the rest are fails, all right? Now, don't worry, your calculator will do this for you very well. Probability of X successes in N trials is binom PDF of NPX. Now, when we're doing most problems, N and P tends to stay the same. P is the proportion of successes. You can think of it as probability, but considering we're already calculating another probability, it's a little confusing. So think of P as the proportion. Now, as you go through questions, the X tends to change. So I might say, oh, what's the probability of 2 successes? That's your x. What's the probability of 5 successes? That's your x. But your n and your p are the same. So if you want to do this on your calculator, basically, I'm doing an example where n is 5, p is 0.3, and x is 2. So that's like our speckled candies. You're going to press second distribution, right there, second distribution. You're going to scroll down to Binomial PDF right there, and then you press enter. Then you're going to see this screen right here, and n is the number of trials or attempts. P is the proportion of successes, all right, think of it as proportion, and x is the number of successes. You scroll to paste and press enter, and it will spit out a value for you. Excuse me. So we're going to revisit the speckled M&Ms example, where n is 5, x is 2, and p is 0.3. If I want 2 successes and 5 trials, and I'm using the fancy formula, and that's for those of you who are going to be doing more stats later or are interested in the formulas, and I get this number. But also, if I do it in my calculator, I get the same number. All right. Now, here's where it gets tricky. What if there are multiple values for x? Say 30% of M&Ms are speckled. What is the probability we'll find up to 2 speckled M&Ms in the first 5 candies? Well, n is 5, and the question is, what is x? All right. Well, I know my proportion is the same. It's 0.30, so these two are going to stay the same. It's really important when you have these words like up to, no more than, at least, to go ahead and write out the sample space. In our case, what counts as up to 2 speckled candies? Well, 3 doesn't count, that's more than. So it would be this set right here. So I'm basically working out the problem for x is 0, x is 1, x is 2. It's like 3 problems. And what I can do is do the problems, the 3 problems, and just add up the answers, and I'm done. But yes, there is a shortcut for probabilities from 0 to a max x value, and it is on your calculator. So if you're going from 0, this only does the left chunk, all right? This shortcut on the calculator, left side, always starting at 0 up to whatever you say your max x is. So how do we do it? Instead of Binomial PDF, you're going to go to Binomial CDF. Notice C stands for cumulative, starting from 0 to whatever. N is the number of trials or attempts, just like before. P is still the proportion of successes. Now, x is the maximum number of successes. You're going from 0 to whatever number you put in here. And it's only going to do the left side chunk, all right? Scroll to paste and press enter. And again, only works for 0 to whatever number you put in there. And yeah, so it only does the left side. What if x is the minimum value? All right. So before we were saying x is the maximum value. If x is the minimum value, what do we do? Well, first of all, always write out the whole sample space. In this case, I'm doing n is 20 and p is 0.1. So we have a nice big sample space. And I ask you, what is the probability of 14 or more successes? Well, I'm looking for these. All of these count as 14 or more. And I want to calculate the probability that x is greater than or equal to 14. That's what I want. Now, what I could do is just add up the probability. Remember, it's p for each individual probability. I could work it out for 14, 15, 16, 17, 18, 19, and 20. But wait, is there an easier way? Well, I'm looking for the right chunk here, all right? What about this left chunk? There's a shortcut for the left side, all right? So basically, calculate this opposite and subtract it from 1. The opposite of x is greater than or equal to 14 is x is less than 14. Technically, it's x is less than or equal to 13. So notice I'm not going to use the 14 in binomial. I'm going to use 13 because I want the chunk going from 13 on down. If you want to get these right, you need to write out the sample space and circle. All right. Now, my answer's not over here. My answer's in the pink. But I can get the green part and subtract it from 1, and that will be it. Okay? Now, let's look at an example of a basketball player that has a 90% shooting average at the free throw line. What is the
probability that the player makes 8 or more shots out of 10 total attempts. Well, it's very important. Get in the habit of writing down what is n and what is p and what is x. So the first thing we see is that p, the probability of making a shot, is 0.90. Always use the decimal value. I know some of you prefer percent. What is the number of attempts? There are 10 total attempts. And what values of x are we looking for? Well, it really helps to write out the whole sample space. And I know that feels tiring and extra work, but if you're missing these, it's because you're not writing this part down. Eventually, you're going to go ahead and be able to skip this, but until you get the hang of it, it's really helpful to write this. So what counts as 8 or more shots out of 10 total attempts? Well, that would be, there we go, those, 8, 9, or 10. Now, I could do binom PDF of 8 and binom PDF of 9 and binom PDF of 10 and add those up, and it'll be just fine. Or what I could do is just look at one problem and say, oh, this is the part I don't want, and subtract that from 1. So my probability that x is equal to 8, 9, or 10 is 1 minus binom CDF, because it's cumulative, of 10. It's always the n, the p, and the x. So 10.90 and 7. And I'll show you how I enter that in the calculator. Notice this is 7. This is the highest of the values that we're removing. So when I plug this into the calculator just for CDF, I get 0.0702 or 0.9298. So how can we quickly enter this in the calculator? We're going to go 1 minus, and you can actually go second distribution. Usually I'm going to do the distribution first, but I'll do it all in order here. So it's kind of like the work I show. Binom CDF. My trials are 10. The p-value we already said was 0.9. And the x value, because this is the part I'm subtracting, it's in that purple circle, it's going to be 7. So I'm subtracting everything that's 7 and lower, hit paste, and then hit enter. And voila, there's our answer, 0.9298. So 1 minus the binom CDF, it's kind of hard to see all this out there, but that will get you the correct answer.
Probabilities, sometimes you get some weird answers, and I just want to make sure you're comfortable with scientific notation. If you get something that looks like this, or it might be EE minus 5, that's the same as 2.3 times 10 to the minus 5. Minus 5 means move the decimal 5 spaces to the left. So in this case, I write out 2.3, and then I go 1, 2, 3, 4, 5. That's where the decimal goes. So the final answer is 0.000000023 in decimal notation.
Now you can also use GeoGebra, and you can find this applet right here, and I'll put a link on the website. And it will also calculate binomial distributions for you. I currently have it set with this little icon, which means you can put in the lowest and the highest value for x, which will work for almost any problem. This is the less than, and this is the greater than, because you're going this value and lower, this one you're going this value and higher. So let's show you how to enter this in. First of all, make sure the drop-down shows a binomial, all right? For n, put in the total number of attempts or trials. For p, put in the success, the probability of success. So this is just like what we did on the calculator. For the blank left of x, put in the lowest allowed value for x. And for the blank to the right of x, go ahead and put the highest allowed value. So you're going to find actually this is kind of easier than using the calculator, because the calculator, when you do multiple values, it only uses this less than. So let's take a look at our example again. All right, oh, there's your 0.7. And that's actually your probability, your answer's right there, okay? And there's what we're normally using. First of all, we still have the same values, all right? Now we're going to go ahead and use GeoGebra to calculate the probability for the same example. So first we need to change n. And we said the total number of attempts is 10. And the probability for this is 0.9, right? And then the lowest value for x we said was 8. And the highest value is 10. And, oops, that did not take there. Let's make sure that's an 8. And now you can see that the probability that the person makes 8, 9, or 10, which is 8 or more shots, is 0.9298.